Yesterday we have seen theoretical aspects of pointers in C, right? With the help of whiteboard. So on whiteboard, I explained about the data segment, the stack, heap, global and static memory area, how variables are declared and at the same time memory is allocated on the stack, and how to declare a pointer variable that I taught you yesterday. Then how to store address of another variable in a pointer variable, that also I taught. I also told you that as far as pointer is concerned, we can keep address of another variable, but inside pointer variable you cannot store actual address. It is not possible. Yesterday I showed you, but today we will write program related with pointers. This will be a basic program of declaration of. We will understand the basics of pointers with the help of simple program. So suppose I declare a variable as x, right? I will go step by step completely. I will store 5 in x. I will initialize this variable because I am not going to scan anything from the user. So the contents of x is equal to %d, and when you print contents of x, you just write x, that's it, right? So there is nothing new in this program, very basic program, and I'll print the value. So x is equal to 5 is printed, right? Now suppose I want to print address of x, right? So address of x, address is always unsigned integer, right? Address cannot be a negative address, right? Like your roll number cannot be negative, it has to be a positive number. The address is always positive. So we use the format specifier for printing address as a %u, right? On Linux system, they use as the %, I think p, right? %u is not valid on Linux based system. I don't know which compiler is going to be used in your college. I think colleges use Linux operating system only because it is free. So how to print the address of x? We'll write address of x. Right? First, this is the first time inside printf function we are attaching ampersand operator to a variable. So this is address of x. We are trying to print address of x. So address of x is 642268. Right? Fine. I'll declare all type of variables. I'll declare float p, right? Is equal to 3.25 f and char ch equal to, suppose I assign some variable, suppose let's assign c. So I'll copy paste so that we can save time. So if p is equal to, here I will write p, instead of percent I will write f, and address of p, it will be again unsigned integer and address of p, right? Here I will print ch is equal to %c, and here I will write ch, and address of ch also I will print and ch, right? So if I run this code, what happened? There will be here. Made a mistake. So observe this carefully now. Output x is equal to 5. This is the address of x. Then this contents of p. This is address of p. This is ch and address of ch. So how it is stored in the memory? Three variables are declared, right? X, p, and ch. What is the address of x? Okay, we will draw that. So this is x, 4 bytes of memory. This is x, right? Then p, float variable. Address is 4 less than this x. So it is somewhere here inside the memory. So this is p, right? Now what is the address of ch? 1 less than, because ch checks 1 byte of memory. So it is c. So this is c. So this contains 5, then 3.25, 3.25, and here it is c. This is ch, not c, right? So on the data segment, if I draw a data segment, this is the data segment, this is the stack portion, right? Inside stack portion, this is x, this is p, and this is ch. So likewise, memory has been allocated, right? So what is the address of x? 6 equal to 68, right? 642268. So this is address 642268. The address of this, right? Then address of this variable is 642264. Right? This is this address, right? This address, this, and address of ch 642263. So likewise, address 62 has been given inside the memory. It is now which address to be given for AX, P, CH. It is sole responsibility and sole work of operating system. Okay, we don't have control over that. So every machine has got different. I mean, if you write the same program, you will get different addresses. If you run the program multiple times, it may happen that you will get different addresses at each time. At the same time, various IDs will give you different address. So sometimes it may happen that if now this X, P, and CH have been stored in this manner, okay, on some other IDs, it may happen that X will be stored like this, then here Y will be there, and CH will be there. Okay, on some machines it may happen that X, sorry, it will be given memory here. Somewhere here P will be given memory, and somewhere here X will be given memory. So it is up to the this thing, uh, ID and operating system and compiler implementation. So a lot of factors come into the picture. So there is no guarantee, okay, how these addresses will be given, how this memory is allocated. You should know that. Now I will again come back to the program. Now suppose I want to store all these addresses in a pointer variable. So I will have to declare pointer variable as int, okay, star, suppose iptr. Okay. iptr I am giving name only because I want to know it is an integer ptr because it is just a variable. Now pointer can be declared in multiple ways. This is one way, this is another way, or this is the third way. I mean star can be written close or close to variable name or in between that. Whatever style you follow, keep that always. Okay, be consistent along with the style. Right. So many students write like this, or it may happen they write like this. It has got pros and cons that I will tell some other time. What are pros and cons of that? So int star iptr, then float float star fptr and char star cptr. So these are just three pointers now. So suppose I want to print now. Okay, contents of iptr. What I mean? Contents of iptr. Intentionally, I am putting percent %u. Right? We can write percent %d, no problem. I will write percent %d. Let's check what happens. iptr, because iptr is a pointer, right? Here I will write some slash in so that we come to know. I mean, some division will be there, otherwise there will be complete mess. Right? Here I have to put single slash in. Let me run the code. Okay, I have not terminated this code yet. Fine. So observe carefully. What are the outputs? These are same, okay, but there you can see now. Now it has become 56. Right? I told you, no, multiple times here on the program, each time address may be different. Okay. So initially it was something 64 or 68, I think. The pattern is same 56, 52, and 51. Earlier it was 68, 64, and 63. Nowadays it has changed. And contents of IPTR, that is 70, 8, and 7. These are completely junk values, right? These are completely junk values. So what is the situation right now? Situation right now is that we have declared three pointers. So this is IPTR, this is FPTR, right? Where it is, I need to get one the digital pad for teaching. That will be nice idea. All right. So this is IPTR, this is FPTR, this is CPTR. Note that point memory allocated for the pointer is not on the basis of data type. What I mean, integer pointer will take 4 bytes, float pointer will take 4 bytes, and character pointer will take 1 byte. No, it is a pointer. It is going to contain address. Address is unsigned, so it is 4 bytes. That's it, right? So these are now uninitialized pointers because these are not pointing anywhere. So these are uninitialized, right? It has got some garbage values, what I have seen already. Now we will store addresses of variables. I will write IPTR is equal to ampersand x, because in the integer pointer you have to store address of integer variable. FPTR is equal to ampersand P, and CPTR is equal to ampersand CH, right? Now what has happened? Now, when these statements are executed, right, this will start pointing here. Since this is a pointer, this will start pointing here, right? And this will start pointing here. So likewise, suppose three variables are there. I mean, three pointer variables are there, right? This is IPTR, this is FPTR, and this is CPTR, right? So when these three statements are executed, it will start pointing. This will point here. Why it will start pointing here? You have written the statement as IPTR is equal to ampersand X. So here 64222268 is there. That's why you start pointing to X. Okay. Here it is 642222. Okay, right here 1 actually number less than what was there. Sorry for that. It will be 64 and it will be 642223. So this will point here and this will point here, right? That's why IPTR is a pointer to X, FPTR is a pointer to P, and CPTR is a pointer to CH, right? Now, what next? We will now print. Okay. What is the need of the pointer? First of all, I told you with the aid of pointer you can access original variable. So now I will write X is equal to %t, right? And now I will not write X. I will write star of IPTR. This is called indirection operator. Indirection. Star of IPTR. And P is equal to %f/n and star of FPTR. We are attaching the star operator. And CH is equal to %c/n star of CPTR. So if I run this code now, without using X, P or CH, without using directly variable name, you can access contents at the remote location. Yeah, have you seen the here? See, X is equal to 5, P is equal to 3.25, and CH is equal to C. So with the aid of pointer here, how it is possible? Because you are attaching star. So what does the star means? Here, star means you are. What is IPTR? IPTR. What is P? P is 3.25. What is X? 5. What is CH? C. I mean, when we say X, we mean contents of X. When we say P, we mean contents of P. Similarly, when I say IPTR, we mean contents of IPTR. So these are contents of IPTR, right? So what we are trying to do, we are attaching star here, right? We are writing star of IPTR. So what is the meaning of this? Value, right? I will not write like this. I will write in a text box. It's much more easier. Value at the address contained in IPTR. It's the meaning of this statement, right? Value at the address contained in IPTR. So what is the value at address? This is the address. What is the value at this address? This 5. So that's why it prints 5. What is the value at this address? 64 3.25. What is the value at this address? It is C. So using star operator, indirection operator, you can have access to the variable whose address has been kept in that pointer. Very important. So suppose I write here star IPTR is equal to 10, star FPTR is equal to 9.85F, and star of CPTR equal to suppose D. Right? I'm printing again. So what will happen now? Observe carefully. Okay. The contents have been changed. X was initially 5. With the help of pointer, you change the contents of X. With the help of pointer to P, you change the contents of P. With the aid of pointer to CH, you change the contents of CH. So remotely you change the contents. That is the fundamental task of a pointer. Remotely access, remotely change, remotely modify. These are basically pointers. Okay. I mean, crux of pointer lies here. Now, how to use that and that everything we will see afterwards. But you need to understand this first, right? I hope through the simple example, you must have understood basically how pointer work. There are various operations on pointers that we will see in the array chapter, right? But as of now, this is the crux of the pointer, only crux. Now things become complicated only when no you store address of pointer in another variable, right? And that multiple things are possible. That we will right now we will not discuss that, but just giving a hint that there is a variable, and we know that address of that variable can be stored in the pointer variable. Right. Now, using the same philosophy, somebody thinks of storing the address of pointer variable in another variable. So there is a x, there is a variable, there is a PTR, which is a pointer variable. So there is a int x, right? There is an integer pointer. So int star PTR, right? So this is a PTR, right? When I write PTR is equal to ampersand x, this will be pointer to x, right? But don't forget that this PTR is also a variable. It has got its own address. So suppose I declare no, how to store address of a pointer variable? It has to be again pointer, but it will be a pointer of star star PTR, double star, right? Some mail. Suppose I give name variable as PTR underscore PTR, right? So how I will store the address of PTR in another pointer variable? This cannot be a normal pointer because normal pointer can contain address of integer or a float or a character. But this is not a normal pointer. It is I want to store in this ptr underscore ptr. I want to store address of integer pointer, right? I want to store this address here, right? So I will write ptr underscore ptr is equal to ampersand ptr, right? Address of this address, right? When I store address of ptr in ptr underscore ptr, it will be a ptr underscore pointer. Ptr underscore ptr will be a pointer to pointer. Okay, this is a pointer. But what is this? It is a pointer. Okay, so this is how, I mean, and this chain is no limitless. I mean, again this address can be stored, again this address can be stored. Okay, it is up to the programmer's comfort and requirement of the program, okay, requirement of the applications. Okay. So what I want to tell you is that we will now suppose I print the contents of fptr. Suppose, I mean, in the same fashion, suppose I write, right, following sequence. I will write I run the code. Observe carefully. You have to play along with this code with a calm mind. Hmm? So at x, I mean, there's nothing new here. It's 56, 52, and 51. These are junk values because it has not been initialized. The x is equal to p, but contents of iptr. What is that? Contents of iptr is address of x. See, right? Contents of fptr. What are contents of fptr? fptr contains address of p. So these are same. And contents of cptr, which is address of ch. So 51 and 51, right? And as I told you, pointer to the pointer, if I write, we'll check what are addresses. Address of IPTR, because IPTR is a variable. Let it be a pointer variable. It says here. Here I will attach the ampersand sign. Right? It is address. Address. Right? And again compile and run. Now see here. See the pattern. Okay. Now it was again 68, right? 64, 63. Contents of IPTR. These are again some junk values, 4 to 0. Earlier it was 70, 78 something. Now these are changed, right? Now here x is equal to 5 and contents of IPTR is address of x. So these are same, right? Same here, 64, 64. CPT, CIPTR, no, CIPTR, what happens? Okay, some mistake my, so observe carefully everything, right? So x is equal to 5, address of x has been stored in IPTR, right? So these contents are, no, here, not here. These are junk values only because addresses we were not stored at this level, at this point. Addresses were not stored, right? At this point, addresses were not uninitialized pointer. So it contains some junk values like this. Now contents of IPTR is address of X, right? Same. Contents of APTR is address of P, same. And contents of CPTR is the address of CH, same, right? Now here we change the contents of X, P and CH using pointer variable. Now here we are printing address of IPTR. So what is the address of IPTR? 64225652 and 48. Right? You can observe here each of these is taking 4 bytes. Right? So here address of IPTR is having its own address again. Right? Again this address, what we did last time, we stored this address in a pointer to pointer. Right? This address in the pointer to pointer and this address again pointer to pointer. Right? So that is possible. Call by value and write int num, right? Enter number and a percent %t and num. Right? I'll write the function change num, right? I'm sending num here. Printf num is equal to percent %t slash n, right? And write the function here again. PV function call here again. Okay? Before function call, right? After function call, and I write the function definition void change num int, right? This is prototype. What is the objective of this code? Send send one number to the function. And we will try to change it through functions, right? So I'll write void change num index, right? If I write x is equal to x into 5, right? Now, what happened here? Okay, so I run this code. Suppose I enter here 10. The output should be actually 10 and 50. Why? Because you are sending num to the function which is 10. How much we enter? 10. So 10 will be sent here. So it should print before function call num is what? 10. Then num has been sent to the and collected in a variable x. And what we have written here, x is equal to x into 5. So x is equal to 10 into 5. It has been stored again in x, right? So x will be 50. So here it should print 50. Let's check whether it does that, right? It doesn't do anything, okay? Before function call num was 10, after function call num was again, num is again 10. So value of num has not been changed, even though you try to change it in the function, right? You will say, sir, name of variable is different. So I'll write same num, right? That's it, right? Will it make any change? No, don't make any change. Suppose enter 10, will do the same. What do I mean is that through function you cannot change contents of variable in another function. Not possible. What is the remedy over this? Remedy over this is send the address of variable. Right? If you understand this, whatever I'm teaching you, simple code, if you understand this, then you will understand many concepts in C++ and Java and Python. Okay. Students do not understand Python. They finish the course, they get the certificate. But what happens at the machine level, what happens at the memory level, they don't at all understand, because they don't understand the pointer. Because reference concept, there is a reference concept in C++, Java and Python. Reference is based on this concept, right? That's why they do not understand. So if I send the address of a variable, I have to change here the prototype. I have to send, when I say this you may not understand. I'm sending address of a variable. So when you send address of a variable, you know that this is a actual argument. So what should be data type of formal argument? On the basis of what is being sent. So what you are sending, earlier you were sending num, which is integer. So you collected in the integer. Now you are sending what? Address of integer variable. So formal variable should be a integer pointer. So declare here int star, right? Suppose I write ptr. Right? Now I can write here a statement as star ptr is equal to star ptr into 5. Right? And on the basis of this, you have to change the prototype. What should be prototype? Now the change num function is taking address. So you should write int star, not int. Right? So if you run this code, and enter the tail, then the contents of num has been changed. This is a pointer. This is a power of pointer. Through another function, you are changing contents of variable in other function. Okay, which is not possible except pointer. Okay, without using pointer, you cannot do that. It is like example I gave you yesterday. Okay? Without string, okay, you cannot get the kite in the sky. Not possible. Same here. Without pointer, you cannot change contents of variable in another function. This is basically a program was called by a value, and this program using pointer is a call by address. In your book or in your class, they use the word as reference. So you use also reference. Basically, this is not a reference, but everywhere they use the word. So you use also the word same. Okay, at least in your college, right? So this is a call by value and call by reference. When you send variable, when you send address of a variable and try to change contents, this is a call by reference, right? So I think you have understood this code. Hmm? Shall we stop here? Yes, I mean, in the earlier case, I was to write the same program, but I changed my mind. and I taught you simple program. I mean simpler than that. So interchanging contents of two variables. This is a world famous program. Okay? There is a reason for that. Interchanging contents of two variables. There is a reason for that. Hmm? Why it is most popular and why it is fundamental program to understand not only pointers but everywhere. Suppose I declare a two variables like x and y. I will write three in all three programs here right now. Right? In the single file. Okay. This program I have written in the first chapter, if I am not wrong. Okay. With the aid of third variable, interchange contents of two variables. You have already written that. I will write the same code here. Right? Temp is equal to x is equal to y is equal to temp. Right? I will write here print after interchange is equal to percent d I is equal to percent. Right? I will copy this and here also I write. Right? Now, if I run this code and enter two numbers, suppose 55 and 22. Let's write here before interchange. Let me call that system function. System. I don't know whether it works or not. No error is there. Yeah, no error is there. So last time I could not, but probably this is the argument which is required. Okay, fine. Let's see whether it works. I have not used that function in the past. I have read about that, but I have not used that in person. Okay. So enter two numbers 55 and 22. So before interchange, yeah, the function has work. Okay, I will tell you afterwards what exactly. If you can recall, if you can remember, whatever the input we have taken, this much code, it has disappeared because of this function. What does this function do? Whatever is there, it clears that, clear screen. In the Turbo C, there was a function called CLR. Okay, that task is now done by system function CLS, right? So earlier junk is not there, only output is there. So before interchange, x is 25, 55, y is 22. After interchange, the contents of x and y have been interchanged now. Now x contains 22 and y contains 55. Right? This is straightforward program. Now the question is, can we do it? Can we do it with function? This is a big question because since C is a modular programming language, since C is a procedure-oriented programming language, we need to divide the task. Right? So whatever today only I have sent you assignments on functions. So these are not different programs. Some of the programs are same as you saw in the first, second, and third chapter. But now we will write those programs using functions. So here we have to get this work done from function. So I will call the function, suppose swap. Swap is predefined function. I will call the function interchange, right? I will send values of x and y, right? So there will be a function void interchange int comma. I have to send two arguments. There is no question about that, right? This is not required now because that we are going to do in function. So void interchange int x comma int int p int q, right? I'll write same code here. So I will declare temp is equal to p is equal to q and q is equal to temp, right? Same code, because we want to interchange contents of x and y, right? But not inside the main function, but by calling function exclusively written for interchanging contents of two variables. So if I run this code now, suppose I enter 44 and 66. Before interchange 4466, after interchange 4466. No question about that, right? No, this is call by value. This is call by value. Why does this happen? It happens because I have to close this and open again this. Why does this happen? This is the main function. This is the interchange function. There is a x, there is a y, there is a p, there is a q, right? And there is a temp, right? I told you for this function a separate stack is maintained. For this function a separate stack is maintained. When you store x as suppose 5 and y as 10, there is a x, there is a y. This is x, this is y, this is 10, this is 5. When you pass these values by calling the functions of interchange, suppose I just enter, okay, you are sending x and y, right? So contents of x, okay, will be copied to variable p, right? So this is p, so this is y. Contents of y will be copied to q, that is 10, right? Now inside this function, using temporary variable, you are interchanging the contents of p and q. When control goes outside this function, this variable is popped, this variable is popped, stack is destroyed, nothing is there, and when you try to print x and y here, it will print pi 5 and 10. This is a call by reference, right? This is a call by. So it doesn't matter whether you declare formal arguments as p and q, doesn't make difference. This is a function call by value, right? Now let's try another way, third way, right? On the basis of what I took a simple program, if you can recall. Now what I will do, I will not send x and y because I know now I have got a power of pointer. Now I will send address of x, address of y. Now you will say before this, you will say that Sir, we have not returned any value. How will you return values? Because we know that function cannot return more than one value. So you cannot return P and return Q. Not possible. You cannot. You can write two return statements, but you cannot return two values in function, because in function chapter I have taught you this. You cannot return two values. But once even though you write return P and return Q, once return P is executed, again control is not going to come back in the function to execute next statement. No question about that. Once return, that means return. That's it. Finish. Now, since I have got a power of pointer, it's an address of x and y, right? As I told you in the last program, when you are sending addresses, you have to collect it in a pointer, right? If you are going to, suppose if you are going to milk dairy, right? If you are going to a milk dairy to get the milk, you have to take some kettle or some vessel which is made up of steel or kind of that. You cannot take a plastic bag or a paper bag along with you, right? Because you are going to get the milk from that end. And you decide what kind of container you should have. You decide it on the basis of for what you are going to put into that. Same philosophy here. If you are going to send an address, the, the data type of variable on the other side must be a pointer. And same pointer. Same means data type, pointer of that data type. So if you are sending an integer variable x, there has to be a integer pointer. So int star p. If you are sending address of y, which is an integer, there has to be a integer pointer. So int star q. You got that? So p is an integer pointer which contains an address of x. Q is an integer pointer which contains an address of y. This is finish. You have got everything now. What you will do now? Whatever code I am writing, try to observe that. Now I'm not writing. I cannot rather write. Okay, I cannot write temp is equal to p, because p is here left hand, the right hand side doesn't match. Here on the right hand side there is a pointer. Pointer means address. Okay, pointer means address. So on the right hand side there is the address of variable. On the left hand side there is a integer. Integer is equal to address, doesn't match, right? Can you write a statement like suppose salary is equal to distance? No. At one end there is distance, at other end there is a salary. Salary has to be in rupees. Distance is in meters or kilometers. Do you measure distance in rupees? No. So both side must match. That is the basis of C language first chapter, right? So on the right hand side there is address. On the left hand side there is a integer variable, right? So what I will do, I'm going to use this same technique, but I will write here, don't store P in temp, store star P in temp. Okay, store star Q in star P and store temp in star Q. I will explain you all these things with the what is that? Void. Okay, prototype has to be changed. You got the error immediately, right? It has to, prototype has to be changed in star and in star, right? So if you run this code now, if I enter suppose 11 and 99, no change. X is equal to 11, y is equal to 99, and after interchange, x is equal to 99 and y is equal to 11. So contents of x and y have been interchanged using pointers. This is basically a call by reference. Now, how does it work? Next question. We'll come to that. Right? The same here. Okay. Okay. This much part. So this is the main function. This is interchange function. So there is a x, there is a y. Right? X has been given memory, y has been given memory. This is x, this is y. Right? Now this has got some address. Suppose this address is suppose small address I will take 1582. Right? This is at this address is 4642. Right? This is the address of x and address of y. Now what I am doing here now in the call by reference, I'm not sending x and y because problem of calling function by reference, you in the last whiteboard presentation I showed you. I'm sending not x and y, but I'm sending address of 1582 address of x, which is 1582, and address of y. So when you send the address at the other end, you created a pointer variable. So you created p and q, right? So this is p and this is q. But p and q are not integer variable. These are integer pointers, right? In the earlier pointer basics, I taught you that you used to declare variable as int x, right? You used to declare variable as int star ptr, right? And you used to store address of x in a ptr, right? Okay. Probably you are confused because of this statement doesn't exist here, if I'm not wrong. Okay, but it exists. Okay, statement exists. Suppose these three statements, these two statements can be combined in a single statement, right? Int star ptr and ptr is equal to ampersand. Instead of this, I can write int star ptr is equal to ampersand x. Same thing, right? What is same thing? Int star ptr is the integer pointer, and in that ptr I am storing address of x. Same. Okay. This is a declaration and assignment. This is initialization. Same thing, right? Same we are doing here. You are declaring a pointer as int star ptr, right? And int star, sorry, int star p and int star q. So here now p is a pointer variable. You are storing an address of x. So p now contains 1582 and q now contains 4642. Right? That is the reason p is a pointer to x and q is a pointer to y. Now next three statements are no This is something which you need to understand. I mean, beginner students fail to understand that. How I will tell you. There is a normal variable here, normal integer variable, which is not a pointer, just normal integer variable. So this is a temp. Okay, temporary variable, we are going to use it for interchanging. Now, what is our objective is interchange storing content of x in y and y in x, right? Call by value doesn't help. Interchange, I mean, contents are interchanged, but only in the function, not in the main function. Okay. So what we can do is write first statement as temp. Okay. Anyhow, we have to use the temporary variable, right? Temp is equal to, because it is like, suppose one glass contains uh, milk and another glass contain water. We want to interchange that. To interchange that, we need third glass. Same philosophy here. Okay, I will share one video along with you. There is one glass, there is another glass. This contains water, this contains milk. Right? If you want to interchange this, you need third glass. Okay, so that you will take this here, and this here, so that it will be interchanged. Same thing here. Temp, temp is equal to, you are not writing temp, you are not writing p, because you cannot write p because p contains an address. But definitely we know that star p is this value, and you want to do the same thing. So I will write temp is equal to star p, because we know that what is star p? Value at the address, at this address. What is value at this address? 5. Store it where? 10. So 5 will be stored here, right? Suppose this is 10. What is the next statement? Star p is equal to star q, right? This statement again is very important. You are not storing q in p. You are storing star q. What is q? 4642. What is star of that? 10. Where you want to where you want to store it? Okay, you want to store it here. So where? What is this? Star p. So star q is assigned to star p. So here directly you are storing 10 to at this location. So what will happen? 10 will be here. Ten has come. No? Next statement is simple. Star q, we want to store now contents of temp in y. So star q is equal to temp. Temp, what is that? 5. Where to keep? Not in q, but star q. Star q means store the value, okay, where q is pointing. Where q is pointing? At this location. Store that 5 here. So store it here. So these will be contents stored here. So ultimately, initially x was containing 5 and y was containing 10. Now x contains 10 and y contains 5. This you did with the help of a pointer. Got that? Have you understood all these things?